This is section 1.3 video 2, and today we're going to be focusing on piecewise functions. So basically functions that come in parts. So the first thing we need to do is understand how to write a piecewise function and what the different parts mean. Now, an easiest way to talk about this, I think, is with cell phones. Everyone understands cell phone minutes. So the first question here we're going to use is this idea that we have a cell phone company and they offer a plan. They offer $20 a month, and that gets you 60 minutes. Now, after that, you're going to have to pay an additional 40 cents for every minute. So we need a function to represent this, but there's two different things that are happening. We're paying one amount up to 60 minutes, and then we're paying a different amount after we go over 60 minutes. So we need to try to write a function that has two parts to it. So in order to do this, let's start with calling our function, we'll say c of t, where time is t and c, just because it stands for cell phone. It's like saying f of x or anything else you want. Now, we're going to put a big bracket here that I'm not real good at drawing because we're going to have two different parts. Now, the first part is pretty straightforward. We're going to pay $20, and that's it. But we need to specify when we're going to pay $20. So over here on this side, we're going to say we're going to pay $20 if our time is between 0 and 60 minutes. So we'll say 0 less than or equal to 60 minutes. So if our t is between 0 and 60, we're going to use the first part of that function. Now, the second part of our function is going to be if we're using more than 60 minutes. So then what's going to happen? Well, the next thing that would happen if we have more than 60 minutes is we're going to pay $20 still. But we're going to have to add some to that. What are we going to add to that? We're going to add 40 cents per extra minute. So we're going to take our 40 cents and we're going to multiply it by whatever our minutes are, but we got to take away that 60 we already paid for. And that would be the second part of the function. So we have $20 plus 40 cents times whatever difference from our original 60 minutes. Now again, notice that there's two different pieces given what your t value is. So depending on your minutes will tell you which of those parts to look at. That's why it's called a piecewise function, because it has two different pieces. So now taking that answer, we can go ahead and look at some examples. The first would be to find c of 45. So if I talk for 45 minutes, how much money am I going to have to pay? Now the first thing we're going to have to do is we'll have to decide for 45 minutes which part of the function do I use. Do I use piece 1 or do I use piece 2? Now it looks like 45 minutes is going to fall in place right here. So we're going to use the first piece of the function. So this is pretty straightforward. 45 minutes is just going to cost me $20. And that's it. Now the next one here, we're talking about 60 minutes. So now we're finding c of 60. And again, we have to decide which piece of my function should I use. Well, for 60 minutes, it looks like we're equal to 60. So we're still using that top one. So again, we're still using the top and saying another $20. And how about the last one? For the last one, we are talking for 90 minutes. So now which one do I use for 90 minutes? Well, 90 minutes is greater than 60, so it looks like I'm going to use this one here. So in this case, we are going to take that 20 plus our 40 cents times 90 minus 60, our difference there. So we're going to get 20 plus 40 cents times, it looks like we're talking for an extra 30 minutes. So we'll do our little multiplying there. 0.40 times 30 is 12. So we get a total of $32. So in this case, I would be paying $32. It looks like an extra $12 just for those 30 minutes. So the real big thing you have to do when you're evaluating with piecewise functions is you have to decide which part of the function are you going to use by looking at your domain. Where does your x value fall in your domain, in your limitations? So here's your multiple choice question. You'll notice now that your piecewise function has 3 pieces and you're finding f of -1. So go ahead, find that answer and plug it into your Google form, and then you can continue on with your video. So now we're going to take it one step further and we're going to graph our piecewise functions. Now when graphing these, it's probably important that you're using pencil and you have an eraser, and you'll see why as I go through this. So just as we did before, we're going to just start with one piece at a time. So the first piece we're going to start with is at the top, and it looks like on the top I'm going to graph this just as if it was f of x equals 3. Now don't get confused. This is the same thing as saying y equals 3, and hopefully you remember that a y equals line is a horizontal line. Every y value is 3. So if this was just a regular old equation, graph y equals 3, f of x equals 3, you would just go and you'd graph a horizontal line at 3, and that would be it. But now we have some limitations. We only want that to happen from -infinity to +3. Notice a mistake here. There's an equal to with that infinity sign. That should not be there, so it should just be less than. So we're going to go to +3. That's going to be our ending point, and we're including it because there's a line underneath there. So this line is going to go from -infinity all the way to +3. So we're going to stop that graph at +3. So I'm going to erase everything after that because that's the only x's I want, from -infinity to +3. We're going to do the same thing with the second piece. So now we're going to graph, and I'll use a different color so you can see the difference. We're going to graph f of x equals 2x minus 3. And again, just like we did before, let's just start by graphing it just as we normally would. So graphing a line, it looks like my y-intercept here is -3, and my slope is 2, so we'll go up 2/1. Now, I made a mistake there. Let's try again. Up 2/1. There we go. I'm going to wait to draw my line in for just a moment. Well, you can draw your line in if you want. You'll notice that now there's that 2x minus 3, but I have to grab my eraser because I only want this function for where the x values are bigger than 3. So that means everything smaller than 3 wouldn't be there. Normally here at the end point, because it's less than, I would put an open circle, but notice that our graph from the first piece actually covers that spot, so it ends up being filled in, and you don't even really need a dot there, we just know that it extends. And so now if you put those two pieces together, we know that our graph is a horizontal line for a while, and then it starts growing. So you're paying a consistent amount for a while, and then after that you start paying more. That's the idea here with this picture. Let's graph one more. This is a little bit bigger now because we have 3 different pieces. So we'll do the same thing we did before and just start one piece at a time. The first piece is 2x plus 1. So then we want to just go ahead and graph y equals 2x plus 1. So we'll put a dot on our y-intercept and we'll go up 2/1. Up 2/1. And down 2, back 1. I'll just go both ways. We would draw this line in here. But notice that we only want it for the x's that are less than -1, meaning smaller than -1. So I'm going to go to x equals -1, and I'm going to erase everything bigger. And we were filled in. Let's see. Let's fix that again. I think I erased too much. So we'll go back to down 2, back 1. And so we want to go to here. All right, there. That's better. All right. The next piece is y equals -2. So that's just a horizontal line at -2. Now in this case, I'm just going to make sure I draw it only where I need it, and I need it from -1 to +1. So I'm going to go to -2, and at -2, I'm going to go from -1 to +1. and draw a line in between those. We're including both of those points, so they are in fact going to be closed circles there. I want to go back to the purple one just for a minute, the top one, and revisit one thing. Notice here how we have x is less than -1 and not including. That means that point right there should be an open circle, not a closed circle, because we don't want to include that. We want to stop there. But then it gets filled in down with the red. Finally, the last piece of our graph is going to go from +1 on, and it's x equals -3. First, let's just graph this as normal. So I'm going to go to -3 and put a dot, and then I'm going to go up 1 over 1, up 1 over 1, on and on and on. And I really only care about this from +1 on, so I'm going to just start at +1 and draw it there. And it's going to be a closed circle because it's going to be an open circle because we're not including +1. So there we go. You can see those 3 pieces of that graph are drawn in there. Here's your free response question. It deals with a life insurance policy. And basically, just reading through that question, I want to know how much it's going to cost you for 10 units of coverage. And then this is where your video will end for today.